Okay, finishing up our last linear programming problem. We're at the denouement. We're at the end. And I've shrunk this down and cleaned it up a little bit so that I can get across a pretty strong point. In this particular situation, there's no way that 0, 0 gives us any kind of profits. If I make 0 pants and 0 jackets, my profit is 0. So that is not a maximum. It should go ahead and have to be tested. And by tested, I mean that we're at a point now where we have a table of values. We have a series of x's and y's. Each one of these are critical points. Each one of those big red dots on our graph. These are critical points, and we know what all of these points now are. Our first one is going to be 0, 0. I should test it, and we're going to leave it in there. It is a critical point. Another one of our critical points is 0 is x and y is 6. What that means is that is a potential profit calculation I can do if I make no pants and only 6 sets of jackets. What is the profit if I do that? Another point is, what if I make 7.5? Well, wait a minute. Can you make 7.5 pairs of pants? No, you can't. Even though the equation says 7.5, even though that is a critical point, it's, from a profit perspective, you can't make half a pair of pants. There's no profit. Nobody's going to buy them. So 7.5 is not a reasonable possible solution. So what would our equation look like if x were 7? What would y be? Well, it's going to be somewhere in this neighborhood, but let's keep moving along. 7.5 and we don't know. Or 7 and we don't know. Our other one is 6.3. We can make 6 pairs of pants and 3 jackets and generate a profit. This idea, though, that we have just changed one of our critical points. One of our critical points is 7.5, but in the reality of the equation, we can't do that. So we need a y value. We need to know what else can we do at that particular point where x is 7. So let's try and figure that out. Does it sit on this line? No, it doesn't. So that's not an equation that we would want to test 7. But on this line, we can find 7. In fact, it does sit on that line. It sits right on that point. Excuse me, sits right on that line. So what is y? And I said, what is y? So y equals -2 times 7 plus 15. What is my y value when I make 7 pairs of pants? -14 plus 15, y equals 1. So when I make 7 pair of pants, I can make 1 jacket, and that is a reasonable solution, if you will, when we have a real-life situation. We can't make 7.5 pairs of pants. So what are my profits? What is my profit? Okay, profit. For every pair of pants, I make $2, and for every jacket, I make $1.50. If I make 0, then my profit is 0. When I make no pants and 6 jackets, then my profit is $2 for every pair of pants and $1.50 for every jacket. That's 1.5 times 6. Well, 6 times 1, that's 6. 6 times a half is another half of 6, that's 3, so my profit is 9. When I have 7 and 1, my profit is going to be $2 for every jacket, $2 for every pair of pants, which is X, and $1.50 for every jacket. Well, that's going to be 14 plus $1.50, that's going to be $15.50 profit. So thus far, 0 is thrown out. That's not a maximum profit. And $15.50 is more than 9, so that's not Neither one of those are good solutions. So right now, this is my closest one. Let's try our last critical point. Profit is going to be for this critical point 6.3. 6.3. So profit, $2 for every pair of pants, and $1.50 profit for every jacket. And that being the case, we have 12. 2 times 6 is 12. Here we have 3 times $1.50. 3 times 1 is 3. And then 3 times 50 cents is 1.5. 12 and 3 is 15, plus another 1 is 16, plus 50 cents, $16.50. I'm going to stop here because that's all the math, but when it comes time to communicate it, you will need to put this back into English such that anyone, a non-mathematician, could look at this and say, okay, our maximum profit is $16.50 when we manufacture 6 pair of pants and 3 jackets. And the reason is, and that's when you would start to elaborate. Have a good evening.